Hello, friends of Euclid. Welcome to Lesson 1-5. This presentation is for the last lesson in Chapter 1, and its learning target is: I know that conclusions based on appearances or guessing may not always be correct. This is kind of where we've come to. That's why the title of this lesson is We Can't Go On Like This. We need an organized system, and that's what's coming up in the book. But in the meantime, you have this lesson, and you are learning the story about the ancient Egyptian area formula that the tax assessors in ancient Egypt used to calculate how much the taxes should be for the landowners. And just to get you familiar with how you use that formula and how you make comparisons between that formula to show that it's correct or incorrect in calculating the area, this presentation is being made. So we are going to use both the Egyptian area formula and our standard area formula, the rectangle, to calculate the areas of the two quadrilaterals below here. So we have this rectangle, and that's a 5 by 4 inch. Then we have this this rhombus here that is 15 units on each side. So here's the Egyptian area formula, and the way it works is that you go consecutively around, so you're matching opposite sides in the same set of parentheses. So A and C here, B and D here, and you do the same thing. Doesn't matter where you start, because you're always going to be matching opposite sides. Anyway, let's look at the next slide to see how we do this calculating. So here we have the Egyptian formula, and as you can see, we've matched up opposite sides. 1/4 times 4 plus 4, that quantity, and then the quantity 5 plus 5, and do the order of operations. And we get 8 times 10, that is 80, and 1/4 of 80 is 20. So 20 units squared, the area for this rectangle using the Egyptian formula. Well, if we use our standard length times width formula for area, we get the same thing. So in this case, the Egyptian formula did calculate the area correctly. And now let's look at the other one. So here is our rhombus that has been superimposed on a grid so that we can make some comparisons. Using the Egyptian formula, we have all the sides are 15, so 1/4 times the quantity 15 plus 15 times the quantity 15 plus 15, so that's 1/4 times 30 times 30. 30 times 30 is 900, so 1/4 of 900 is 225 units squared. Well, this is not a rectangle at this time, so how do we know if this is correct? And it says in the book that the Egyptians knew that it didn't always give them the correct area, but they weren't quite sure how to fix it. So let's take a look at this. So we've taken this one again, and we'll bring that math from the Egyptian formula back out. And here's one thing that you can do to make a comparison. We can cut this right triangle off of this side and then add it over here to this side. And this way we can make a rectangle. So we can use our rectangle formula, and it's a little bit easier to see what the area is. And as this one shows down here, now we've got our triangle reattached, so we've got a 15 by 14 rectangle. So now we can calculate that area. It's 210 units squared is the correct area, not 225 units squared. So this is a case where the Egyptian formula didn't work. What we kind of discovered is that it does work on rectangles, but it doesn't work on other quadrilaterals. So, and later on in the course, you'll learn the parallelogram formula, which is area equals base times the height. And so if we have a parallelogram, this is how we can find the, okay, so there is our altitude or height. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 units. Just like we figured here. So 15 times 14, so that yields 210. So another way of showing that 225 units squared is the wrong area. So now you know a little bit about how to use the Egyptian formula for area of a quadrilateral here, and also how to test it out to make sure it yields the correct area. And in this case we did this by turning this into a rectangle and showing that as a rectangle it's much easier to tell the area is in this case 210 units squared. Alright, that's it. Thank you very much and have a geometric day.